Okay, gang, we're doing 27. So let's see what you got going on here. You've got a baseball diamond. I'm just drawing that real quick. The shape of a square. Each side's 90 feet long. A player runs from second base to third base at a speed of 25 feet per second. And what rate is player distant from home? Alright. So the person is somewhere between, this is second base here, and this is third. And the person is somewhere here, running this way. Let me draw this a little better, because I think if you don't see this clearly, it gets really confusing fast. This is actually a right triangle there. So hold on a second. Let me draw that better. Let me flatten it on the, let me sort of turn it to the side. So if I sort of rotate it a little bit to the right, you might see it a little bit better. So it's like this. Okay, so I just sort of tilted it up a little bit. Alright, so the guy's running from here to here. So would we say this side changes? Yes, that side would change. So maybe let's call it an X. Now, the player was just over here on this side. It's not, the player isn't on this side yet. So this side will be fixed at the 90 feet that they mentioned in the problem. Now, will this side change as the runner goes to the base? Would you say that the magnitude of this side would change? Right, you'd be right if you're saying yes, it does. Alright, so it looks like this. In terms of just the general, before I grab like too much data, this is what the general picture looks like. This side's fixed, because we're not talking about when the player turns the corner. We're just talking about here. Alright, so this side is fixed, but these two sides are going to change. So what equation would we use for the general? Good, we would use Pythagorean's theorem. Alright, so for the general I love the way my brain sometimes works. For the equation, that's always off the general. So let's use Pythagorean theorem. So we're going to do x squared plus 90 squared equals to s squared. Now remember, s is the hypotenuse because it's across from the 90 degrees. So that guy has to be on the end by itself. And let's just go ahead with the derivative while we're at it. We're going to do that in respect to time. So derivative of the 2 is the 2x. Derivative of the x itself is dx dt. Derivative of a constant is 0. That goes to 0. Alright, now derivative of s squared. So derivative of 2 is 2s. Derivative of the s is ds dt. So remember, x and s are dependent on time. That's why there's dx dt and ds dt. Okay, now let's just fiddle with this a little bit longer before I start to figure out what we need to isolate. I see that there's a 2 on both sides, so let's just go ahead and divide that off. So if we divide both sides by 2, we're going to get x dx dt equals to s ds dt. Alright, so now let's go back to the problem. So I'll read it as you're looking at my pencil here. A player running from second base to third base at a speed of 25 feet per second. Okay. This player is running at a speed of 25 feet per second. Now remember, when you write down what the derivatives are, and since this is side x to us, the derivative of this side would be dx dt, because it's the rate of the side of x. It's the rate of the side of x. Now when they say it's 25 feet per second, do you want to say that that's positive or negative as this guy runs this way? Can you see the movie? He'll be here, then here, then here, right? So this side is getting smaller as the guy runs to third base. So make sure when you write your dx dt, you say that it's negative 25 feet per second. All right. So he's running at 25 feet per second when he's 20 feet from third base. So when he's the distance here, when he's 20 feet to getting to here. So in the snapshot, I'm drawing the snapshot now. In the snapshot, this is 20 feet. Okay, this is 20 feet. This will still be 90 feet. We don't quite know what this guy is, but we can figure this one out. All right, at what rate is the player's distance from home plate changing? All right, so the player, now they want to know the rate that the player is from home plate. Home plate is here. So the rate that this line is, the rate of S, like how that changes with time. So we're solving for the rate of S. So we're solving for ds dt. So to solve for ds dt, I just want to move the S to the other side. So now I'm going to isolate ds dt because that's what I want. So I'm going to divide the S out. I just sort of transposed it as I wrote it. Hopefully everybody can see that. Like if you divide this by S, that's that, and that's equal to that. All right, and now all we have to do is the plug-in, and remember the plug-in is from the specific. So we have that over here. We're just missing a little bit of information, right? We have X, that's 20. We have dx dt, that's negative 25. We don't have S. So how are we going to find S here in this diagram? Good, we're going to use Pythagorean Theorem, right? So 90 squared plus 20 squared equals to S squared, because that's the hypotenuse we're missing. Okay, let me see what kind of numbers we're looking at. All right, well, we can see that the 100 would come out as a 10. The 2 zeros would come, that's 100, come out as a 10. 85, that 5 would go in there 17 times. Oh, I think that's pretty much it. All right, so let me just crunch that out. I'll just do it, I think I'll just put it in as the square root of 8500. So it's about 92.2. I can see it's just not going to be like, well, you can put it over here as a radical, but you're going to have to do something with it eventually because it's not going to come out to a solid number, a whole number. All right, so I'm going to use 92.2 feet for S. All right, gang, here we are. This is the finale. X we said was 20. dx dt we said was negative 25, and S we calculated as 92.2 when we put that in the calculator. So let's now round this off. So you've got 20 times negative 20 times negative 25 divided by 92.2. Okay, negative 5.4. Let me get my units right. So S is linear, so it's one dimension, so that's just feet. Time is seconds. Okay, so negative 5.4 seconds. So that basically means, right, because it's negative, is that the distance from the player to home, that the distance from the player to home plate is shrinking. So that's good, right? That's what the guy running the bases wants to do. He wants to get closer to scoring a home run. So that's what he's doing. He's getting closer to the plate. We can see by the negative on the rate of S. All right, gang. That's it on this one. Catch you. Bye-bye.